square minus 2018x plus 2017 to the power x square minus 1 is equals to 1, and our target is to find the number of possible values of x. See, this side we have some base to the power, base and power, exponential form, and this side we have 1. See, this 1 can be expressed in many ways. Okay, this 1 can be expressed as something to the power 0. This 1 can be expressed as 1 power anything. This 1 can be expressed as minus 1 to the power even. See, there are different possibilities. 1 can be expressed like something to the power 0, 1 power anything, and minus 1 power even. So in these three cases we need to analyze the problem to get the number of values of x. See, first case is anything to the power 0, right? So just I am solving in the first case. So as per that first case, left hand side is x square minus 2018x plus 2017 to the power x square minus 1. And whereas the right hand side 1 can be expressed as x square minus 2018x plus 2017 to the power 0. So when you observe, see, left side is just I am writing as it is, and whereas right side is this base to the power 0. Since bases are equal, we need to equalize the powers. So x square minus 1 is equals to 0, and the values of x are 1 or minus 1. Value of x is what? 1 or minus 1. Here we need to check. See, the value of x is 1 or minus 1, but when you replace x is equals to 1, at x is equals to 1, if you replace x with 1 here, this base will become 0. 1 minus 2018 plus 2017, that in the sense 0, and the power is again 0. 0 power 0 is what? Not exist. Okay, at x is equals to 1, we are getting LHS is equals to RHS is equals to 0 power 0. This is not possible, so you just neglect x value as 1. But at x is equals to minus 1, it is acceptable. Okay, x is equals to 1 is not acceptable, x is equals to minus 1 is acceptable. So from this first case we have only one value for x, and that value is minus 1. Okay, right. And now you just think about 1 power any number. Second case, I am trying to solve the problem in second case. See, in the second case, I will just view this 1 as 1 power x square minus 1. Left side is just like left hand side, right hand side is just what? Right hand side is this 1. And I am trying to write this 1 as 1 power x square minus 1. Okay, right. So left hand side is this given problem, and for this given problem as well as for this 1 power x square minus 1, x square minus 1 is a common thing, so you need to equalize base. Okay, this base to that 1. Okay, that implies x square minus 2018x plus 2017 is equals to 1. Okay, yeah, we need to get the values of x. How to solve this? Just have a look. X square minus 2018x plus 2017 is equals to 1, and that implies x square minus 2018x plus 2016 is equals to 0. Is it right? So three relations are given in terms of x, y, z. X plus y whole square minus z square is equals to 0. Y plus z whole square minus x square is equals to 24. Z plus x whole square minus y square is equals to 12. And we need to find x plus y plus z to the power z. Okay, right. How to solve this? See, x plus y whole square minus z square is equals to 0. So using a square minus b square, we have a chance to write it like a plus b into a minus b. So from there I will conclude that x plus y plus z into x plus y minus z is equals to 0. So a plus b into a minus b. X plus y plus z into x plus y minus z is equals to 0. And from the second statement again, y plus z plus x into y plus z minus x is equals to 24. So again a square minus b square, y plus z plus x into y plus z minus x, and that implies z plus x plus y. So again a square minus b square, a plus b into a minus b, and here it is z plus x minus y, and that is equals to 12. Our target is to find the values of x, y and z. Here, see how to do, how can we move further. You just have a look, and I am going to add these three equations, and in these three equations x plus y plus z, x plus y plus z, x plus y plus z is a common thing. You just pick out that x plus y plus z. When you have that x plus y plus z as a common thing, look here, we need to add these three. While adding, y and y gets cancelled, x and x gets cancelled, one more z gets cancelled, again you will get x plus y plus z. And here if you add, that is 36. And finally you have x plus y plus z is equals to 6. Yeah, right. After having x plus y plus z, since our target is to find x, y, z or z, replace x plus y plus z in the given relations. So if you replace x plus y plus z with 6 in all the three, then you have three more relations, and they are x plus y minus z is equals to 0, y plus z minus x is equals to 4. Why? Because since it is 6, send that side. Since it is 6, send that side, you will get that z plus x minus y is equals to 2. Right. Using the 3, now it is easy to calculate the value of x, y and z. Since I need only z, I am concentrating on the z. From here, what is x plus y? X plus y is 6 minus z, right? X plus y is 6 minus z. So replace here 6 minus z. Okay. So just use these three relations. X plus y is 6 minus z. So 6 minus z is equals to 0. 6 minus 2z is equals to 0, and z is equals to 3. So finally you have x plus y plus z as 6, z is as 3, and the question is about finding x plus y plus z to the power z, and your answer for the problem is 6 cube, which is 216. There ends the problem. Right? So this problem needs your algebraic skill completely. Okay? Have a look. Look at the board. The problem is bit logical, and it needs your algebraic skill. X is equals to 2019 divided by square root of 2020 plus 1, fourth root of 2020 plus 1, eighth root of 2020 plus 1, and 16th root of 2020 plus 1. Then we need to find the value of 1 plus x to the power 48. See how to solve. First of all, try to simplify the denominator. And while simplifying the denominator, my idea is, since here root 2020, 4th root 2020, 8th root 2020 and 6th root 2020 are involved, you just take this 6th root 2020 as some constant, like some variable, okay, anything. You just take, okay, 16th root 2020 is equals to some y. If that 16th root 2020 is y, then you know that 2020 is equals to y power 16. Is it right? So now, yeah, what is the denominator? Square root 2020, which is simply y power 8 plus 1, fourth root 2020. So power 1 by 4 we need to consider y power 4 plus 1, and then y square plus 1, and then y plus 1. This is denominator. So now what I do is, I simply multiply this with y minus 1, and I will divide it with y minus 1. If I do, what will happen? See, now this is equals to y plus 1 into y minus 1 is y square minus 1. Y square minus 1 into this y square plus 1 is y power 4 minus 1. And that value into this y power 8 minus 1 into this is y power 16 minus 1 divided by y minus 1. And now what is y power 16? Y power 16 is that 2020 minus 1 is 2019 divided by, we have that y minus 1. Okay, this is the denominator. And if you replace this denominator with this 2019 by y minus 1, 2019 and 2019 gets cancelled, then you will get directly x is equals to y minus 1. Is it right? Just have a look. You need to replace this denominator with this 2019 by y minus 1. 2019 gets cancelled. You will get that x is equals to y minus 1. But our target is to find the value of this 1 plus x power 48. So from there, what you say about x plus 1, which is equals to y. Since we need x plus 1 to the power 48, that implies x plus 1 to the power 48 is equals to y to the power 48. What is y actually? Y is this 16th root 2020. That means 2020 to the power 1 by 16. And whole power 48 is 2020 cube you will get. 1 by 16 into 48. And then your answer for the problem is this 2020 to the power 3. Okay, just have a look. Next problem. See, square root of x is equals to fourth root of 3x power 4 plus 4. Then we need to find out the value of x power 4. See, very simple, I think so. 1 square root means power 1 by 2. Here there are 3 square roots. So you will get 3 1 by 2s as a multiplication. So directly I will write it as x power 1 by 8. 1 by 2 into 1 by 2 into 1 by 2. And here fourth root. 1 fourth root is power 1 by 4. And again 3 fourth roots. So 1 by 4 into 1 by 4 into 1 by 4. So the right hand side is 3x power 4 plus 4 whole to the power 1 by 64. Now, as the next step, you just send this 1 by 64 left side and this power 1 by 8 to that side. Then you will get that x power, or one more thing, just send this 64 this side. X power 64 by 8 is equals to 3x power 4 plus 4. Just simply sending this 64 this side. And 64 by 8 is 8. So you will get x power 8 is equals to 3x power 4 plus 4. Our target is to find the value of x power 4 simply. So take that x power 4 as some t. If you take x power 4 as t, what will happen? Then x power 8 is simply t square is equals to 3t plus 4. If you factorize it to get t, that value of t is the required x power 4. So this implies t square minus 3t minus 4 is equals to 0. And from there you will get that t minus 4 into t plus 1 is equals to 0. Is it right? T square minus 3t minus 4 is equals to 0. And then the value of t is either 4 or minus 1. What is that t? X power 4. So x power 4 is equals to 4 or minus 1. See, x power 4 means an even number in the power. So the result is always positive. So we will accept 4 and we will neglect minus 1. So our answer is 4 and we don't choose minus 1. Okay? Yes. Have a look. See, the question is to count the number of perfect squares which are not perfect cubes below 2021. So we need to identify a number which is a perfect square and not a perfect cube, and that number should less than 2021. First of all, what are the perfect squares below 2021? See, yeah, 1 square, 2 square, 3 square, 4 square, 5 square. Likewise, if you list, you will get what? Perfect squares. So 5 square is 25, and then 36, and then 49, 64, 81, 100. All these are what? Perfect squares below 2021. Okay, right. So you will get many numbers like that. So 11 square, 12, and then up to 15. Okay, and then 16 square, 20 square. So like that, if you extend, see, if you observe, 45 square is 2025. We don't consider this because it is more than 2021. So we need to take below 44 square. So including that 44 square. So number of perfect squares which are less than 2021 are 44. But among these numbers, we need to cancel out some numbers which are perfect cubes. Okay. Perfect cube means what? Perfect cube means what? A number is a perfect cube. What are perfect cubes? You just think here. Okay. Yeah. One square, that means one cube is a perfect cube. One square is one. We also express it like one cube. So we need to neglect it. Is it right? And then two perfect cubes we are thinking. 2 cube won't involve here. 3 cube 27 also not involved here. 4 cube is 64 and which is 80 square. 80 square and 4 cube both are 64s. We have to neglect this again. Okay, 4 cube. 5 cube is 125 not involved here. 6 cube is not there here. Okay, like that you need to check. 7 cube, 8 cube. Okay, is there any possibility of getting 8 cube? No, because 8 is 2 cube. Okay, so that is not a perfect square also. 9 cube. And then next 10 cube not involved here. 11 cube, 12 cube, like that we need to check. So another perfect square, what is that? See, if you think, see these perfect squares, this 8 is a perfect cube actually, this 1 is a perfect cube actually, whose base is a perfect cube, that number will become perfect cube. Somewhere here I will get 27 square. When you think about this 27 square is also a perfect cube, so we need to neglect that 27 square also. 1 square we need to neglect, 8 square we need to neglect, 27 square we need to neglect, and then we need to neglect what? 64 square. But 64 square is not involved in these 44 numbers, so don't bother about that. So there are only 3 numbers which are perfect cubes in this 44. So you need to subtract the 3 and your final answer is 41. So totally there are 41 numbers which are perfect squares and not perfect cubes below 2021. That's it. Okay. Have a look.